Okay, so going back to our patient again. We've got our endotracheal tube. We've got our ventilator. Okay? So what's the purpose of this ventilator? The purpose of the ventilator is to maintain homeostasis between the two gas concentrations that we're talking about here, which is carbon dioxide and oxygen. Okay, so oxygen is being put into the patient and carbon dioxide is coming out. And for the most part, we want to keep those close to normal. There's some exceptions to that. Here's the point though. There's many different ways to put air into somebody, okay? We can say we're going to put air into somebody based on volume, okay? So we're going to put a certain X amount of volume into somebody and then let it come back out. That's one way of doing it. Another way of ventilating somebody is saying we're going to inflate them to a certain pressure. So we're going to have this ventilator put a certain amount of pressure into the patient, and then when that pressure is released, then it's going to come back out. So we can do that. Now, we can do it at a certain rate. We can do this fast, and we can do it slow. Okay, so in other words, how many breaths per minute? We could also adjust the flow rate. So in other words, yes, we can put a certain volume in, but we can give that volume slowly, or we can give that volume very quickly. Okay? The other thing is that we can do is we can decide how much pressure to leave in there at the end of when we put the air in, and then we can decide how much pressure to leave in there after we're done putting the air in. Finally, we can decide how much oxygen we want to put in there. How much? We can put a lot or we can put a little. Now, just to further complicate this, just so you can kind of see where we're going with this, we can have the ventilator be in charge of when the patient gets a breath, or we can have the patient be in charge of when they want to get a breath. So think about all of these different variabilities, and now you can quickly see how there are so many different ways that you can ventilate somebody, and each one of these ways is a different mode of ventilation. You may have heard of these before, like AC or SIMV or pressure support or CPAP. These are all different modes, and we're going to go through some of these modes and show you how it makes sense about how this is working. Okay, so here's our system. Over here we've got the ventilator. Here we've got the tubing that goes to the endotracheal tube down into the lungs. And we've got our balloon here filled with air to make sure nothing else gets down there, and we're ventilating our right lung and our left lung. So let's talk about the first mode of ventilation, and this will become important later. The first mode that I want to talk about is AC. Okay, the other way we call it is assist control. The other name for it also is continuous mandatory ventilation, or CMV. Now, this is the most common mode of ventilation that you'll see, especially on a medicine floor or medicine unit. The key here is that the patient triggers the vent. How does that happen? Well, the patient takes a breath in, and therefore there's a negative pressure here, which causes a negative pressure to be sensed here at the ventilator. The other way you could sense it is by flow, if there is a flow that actually goes through here by the negative pressure. Now, as soon as the ventilator picks up on that negative pressure, it's going to deliver a specific volume. Okay? And so there's an actual dial on here, okay, where you can actually turn the knob to a specific volume, or you can enter it in. And that volume can be anywhere from 500 cc's all the way up to 600 cc's usually. The ideal way of ventilating somebody would be around 8 milliliters per kilogram ideal body weight, okay? So anyway, whatever that volume is, it's going to deliver that specific volume in AC mode ventilation, okay? Now, the patient can trigger it. You could also set up a backup mode or a rate. What does that mean? If I set the rate to, for instance, 12, because there are 12 5-second intervals in 1 minute, that means every 5 seconds, the ventilator will give a breath to the patient of a specific volume every 5 seconds, only if the patient does not take a breath. If the patient is breathing above 12, then the ventilator will only give breaths when the patient triggers it by trying to take a breath in. In other words, if you set the mode to AC, set in a volume, and set a rate of 12, the patient can never breathe less than 12 times per minute. Now, there's something that you should understand about this which is very important. You may recall from chemistry an equation that says PV equals nRT. Now, in this system, temperature is constant. R, of course, is always a constant. N is a constant. And so the thing that you must realize is that pressure and volume are inversely proportional to themselves. In other words, as the volume of a gas goes up, the pressure goes down if you have the same amount of gas. However, the other way of looking at this is compliance, which I'll abbreviate as a C. Compliance is equal to the change in volume over the change in pressure, which means to say that if the pressure changes a little bit and the volume changes a lot, then you have a very compliant lung. If you don't have a very compliant lung, it's going to take a lot of pressure to make just a small amount of change. Here's the point. The point is that these set of lungs have a specific compliance. And if you are delivering a specific volume into these lungs, you are going to get a specific pressure after you deliver that volume. That pressure can change depending on the compliance. The point of this is that you need to have a readout that tells you what the pressure is in that lung, so you can know what the compliance is. So in other words, in this mode of ventilation, you set the tidal volume and the ventilator will tell you what the pressure is. So you're setting the tidal volume, you're setting how much volume of gas is going to go into the lung, and based on the compliance of the lung, it will tell you what the pressure is. If the compliance of the lung goes down, then typically you'll have higher pressures. If the compliance of the lung is very high, in other words, a very compliant lung, then your pressures are going to tend to be on the lower side. Now, let's make this converse to pressure control. In pressure control, what we're doing is we're setting a pressure. In other words, we're going to decide how much pressure we're going to ventilate this patient with. And so, as you can imagine, if we're setting a pressure, there is a specific compliance to this lung, depending on what state it is in. And if we set a certain pressure, if the compliance of this lung is very low, then you can imagine we're going to have lower volumes. However, if the compliance of this lung is very high, then we're going to have higher volumes. Because remember, compliance is equal to the change in volume over the change in pressure. So in pressure control, you can also have the patient or time triggering a set change in pressure. And depending on the compliance, the volume can change. And so the key here is that you need to have alarms set up. And you need to know and understand what those alarms mean. What could happen here, let's for instance say, in a pressure control situation where you're giving a specific pressure, if the compliance of these lungs somehow drop precipitously all of a sudden because of some pathology, which we'll get into, you will notice that the volumes will drop. You would want to know that, and so you could set an alarm on the lower side of the volume so that if the volumes did go down, an alarm would go off saying that you're not ventilating. Conversely, if you were back in our previous mode, which was assist control, and you're setting a certain volume, if the compliance of the lung dropped in that situation, then as you would realize, the pressure would start to go up because you're trying to put a set amount of volume into a low compliant lung. And when that happens, the pressure goes up. The pressure would then trigger an alarm. So the point here is in pressure control, you're setting a pressure and your output to read is your volume. In AC, it's the flip of this. So when we come back, we'll talk about the pressure-volume relationship and a few more modes of mechanical ventilation.